So the last time I saw you, we were talking about the quadratic formula and how the quadratic formula could solve absolutely any equation whatsoever, right? And the quadratic formula was x equals minus b plus or minus the square root of b squared minus 4ac over 2a, right? And we said we could come up with the solutions to any quadratic whatsoever as long as we knew how to use this, right? Today, what we're going to focus on really is just this bit underneath the square root. And that is what we call the discriminant. So today's lesson is going to be on the discriminant. Because what the discriminant itself does, call it little d, equals b squared minus 4ac. And the discriminant tells us what kind of solutions that we're going to have to different quadratic equations, right? So if I have a discriminant that is greater than 0, so that would be a positive number, right? It means that I would have two real solutions. If the discriminant is a perfect square, if it's a perfect square, this is sort of like a subcategory. Then we would know that they are also rational solutions, right? Not a perfect square. We would say that they're irrational, right? We'd still have two of them. They'd still be real solutions, but one would be rational. If that's a perfect square, they're rational. If it's not a perfect square, they're irrational. So if I had a discriminant that equals, if my d equals 81, well, 9 times 9 equals 81. And so therefore we would know it would be two real solutions and they would be rational. Let's say I had a discriminant of 6. Well, 6 isn't a perfect square. Nothing times itself equals 6, right? So I would go, okay, well, I have two real solutions, but they're irrational. Does that make sense? That means something would be left under the square root. So that's for any discriminant that is greater than 0. If the discriminant is equal to 0, we wind up with one solution, and it is real and rational. One real, rational solution. You hear the sirens? It's Popo. So we've done what happens when the discriminant is greater than 0, and we've done what happens when the discriminant is 0. So our last bit is what happens when the discriminant is less than 0. So positive numbers, 0, or a negative number, right? When it is a negative number, we wind up with two imaginary solutions. And if you think about that in terms of where we're getting the discriminant, we are getting the discriminant from what's under the square root in the quadratic formula, right? So if this is a positive number, we're going to have a solution, right? We may have two real solutions. We may have, if it's 0, we may have 0, right? Because the square root of 0 is just 0. And if you remembered when we were doing the quadratic formula, if we ever had a 0 under the square root, we wound up with just one solution. If we have a positive number underneath the square root, we knew we had real solutions. And if we had a negative under the square root, remember we had to pull that negative out as an I. And so that's how we know it would be imaginary. But all we're concerned with, like we don't have to do all of this work in terms of the discriminant. All we have to do is figure out what b squared minus 4ac is. And so all we have to do now is a ton of sample problems, right? And not even a ton, like 4 or 5 sample problems, and they go pretty quick. So our discriminant, again, let me do it in another color because fun. Let's remember that our discriminant equals b squared minus 4 times a times c. So if I have a problem like, for example, 2x squared plus 12x minus 13 equals 0. Well, we know we have to figure out what a, b, and c are because we have to plug them in. So let's look at it. A, b, c. Our a is always the number in front of x squared. If there's no number there, we just put 1. There is a number there, so in this case, our a equals 2. Our b is always the number in front of x. So in this case, b equals 12. And our c is always that number at the end that doesn't have either an x or an x squared, right? It's just a number. And so that would be negative 13. So all we have to do is take those numbers and plug them in, right? To what? To this formula. Our discriminant equals b squared. Well, b squared is just going to be 12 squared minus 4 times a, well, we know that a is 2, times c, which we know is negative 13. So now we just have to solve this. If you don't know how to do it or the numbers get crazy and you can't do them in your head, use a calculator. But the best piece of advice that I could give you when you're doing a problem like this is anytime you're plugging something in, put what you're plugging in into parentheses so that you know to apply it to everything. Like if this was a negative 12 and I didn't have it in parentheses, I might forget that I'm squaring that negative 2. It makes it negative 12 times negative 12, which would have been a positive 144, right? So 12 times 12, well, that's just 144. And then we have negative 4 times 2 is negative 8. And negative 8 times negative 13, well, that is positive 104. There's like 8 car alarms on the street next to me going off all at the same time. Do you hear them? It's crazy. And so when we add those together, we get 248. That is our discriminant. Now, all we have to do is take whatever that solution is. Whoa, I just blew that up. Whatever that solution is, and we have to bring it up here. And we go, okay, well, is it greater than 0, equal to 0, or less than 0? And in this case, 248, that is greater than 0. And so that means that we are going to have 2 real solutions. Is it a perfect square? I can tell you right off the bat that it's not a perfect square, which means that we are going to have 2 real yet irrational solutions. 2 real, irrational solutions. Does that make a little bit of sense to you? Maria, are you feeling it? Cool. All right, so let's try some others, all right? Let's look at Oh, I like this one. What if we have negative x squared plus 16x minus 64 equals 0? Remember, it's all set up equal to 0, so I don't need to fix anything in that. We can easily find our A, our B, and our C. Our A, since there's no number in front of there, it's just 1, but because we have that negative, it's negative 1, right? That's going to be our A. This is going to be our B, whatever's in front of X, so that's just 16. And then our C is its independent roving constant number that we're just going to call negative 64. And we are going to plug it into B squared minus 4 times A times C. Right? In this case, our B is 16. So we are going to have 16 squared minus 4 times A, which is negative 1, and times C, which is negative 64. Now, 16 squared is 256. And now I have negative 4 times negative 1. Well, that's positive 4. But when we multiply that positive 4 times negative 64, we get negative 256. And when I subtract 256 from 256, I just get 0. And so if you go back up to our little chart here, right, when our discriminant equals 0, when D equals 0, we have one real rational solution. And so the discriminant to this, what it tells me is that this quadratic equation will have one real rational solution. Oh, stuff just got weird on me. You guys disappeared from my screen. So we've done two real irrational. We have one real rational. Let's look at this problem right here. Let's look at it in purple. I like purple. The blue's my favorite. Save that for last. What if I have 3x squared plus 24 equals 0? It's set equal to 0, so we should be able to find our A, our B, and our C. And our A is always what is in front of x squared. And so that's just going to be 3. Well, our B is always what's in front of x, and we don't happen to have an x value here. So in that case, if I don't have an x, it means I don't have a B value, which means it is just 0. Now our C is that number that has no x or variable attached to it, right? So our C is just 24. And we can plug those numbers in that way, right? We know that our D equals B squared minus 4 times A times C. And so our B is 0. Well, that's just 0 squared. Minus 4 times A, which is 3, and C, which is 24. So when I do this 0 squared, it pretty much has no relevance in this problem, right? Because 0 times 0 is just 0. So really what we're dealing with is this part right here, right? Which is negative 4 times 3, which is negative 12 times 24. So we wind up with negative 288. A negative 288 is less than 0. So our D, our discriminant, is less than 0. And if you go up to our chart, you could see that when D is less than 0, it means we have two imaginary solutions, right? So that we could say we have 2 imaginary solutions. And what does that tell us? It tells us when it comes time to do the quadratic formula, we know what kind of solutions that we're going to have, right? We're going to have 2, and they are going to be imaginary. I wrote down a couple of more problems for us to work out. I'm going to see if you guys can do one based on this, and I will write it up. I'm going to have you guys kind of work it out. You can put what you get into the chat box. I want you to tell me, is it 2 imaginary, 2 real, or 2 or 1 solution? So I'm going to let you guys give it a try. And we will go with I'm trying to find one with a simpler solution so that you guys aren't doing anything crazy. Let's go with negative 4x squared plus 8x minus 4 equals 0. Remember, you need to figure out what your A equals, your B equals, and your C equals. And you are plugging it into the formula. Your discriminant equals B squared minus 4 times A times C. If D is greater than 0, you have 2 real. If D is equal to 0, you have 1 real. And if D is less than 0, you have 2 imaginary. So I want you guys to solve that problem. I want to see what you get in terms of solutions when you plug those numbers in. I'll stop the video at this point because you guys got the crux of the lesson already. Now we're just doing a little practice.